Hi students, welcome back. Today we are going to look at number of islands problem on LeetCode. Let's look at the problem statement first. So the problem statement says we are given a m by n binary grid which represents a map of land. Okay, ones represent land on the map and zeros represent water. We have to return number of islands in that area. So what is the definition of an island? An island is surrounded by water and is formed by connecting adjacent lands. So, any piece of area which has water surrounded by it is an island. And we can assume that any area outside of this given land is water. Okay. So we are given map of a land, and let's say our land is like this. Okay. It is divided into some grids. Okay. And each grid is represented by a cell in the matrix. If it is 1, that means this much piece of area is land. If it is 0, that means this piece of area is water. Now, if this is water, this will also be 0. And anything outside, all the area outside is water. Okay, we have water everywhere. That is the given statement. Now, let's take a look at few examples and see how we can solve this. So, this is the first example that we are given. So, if you see, let's say you start from the first cell. What is the accessible land from here? You can go here, you can go here, you can go here, 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 and from here you can go here. So, this part of land is connected. Here, rest all are zeros here anyway. Okay, so the number of islands here is total connected areas, which is 1 in this case. Okay, now let's look at the second example. Okay, in the second example, again, let's start at the first land point. This is the one. From here, where can we go? We can go here. From here, we can't go here because it is water, but we can go here and we can go here. Okay. Now all this is water. This is the next land that is found. From here, where can we go? This is surrounded by water. We can't go anywhere. Then what is the next land that we find? This is the one. Okay. Where can we go from here? We can only go till here. Okay. So how many land areas did we find? We found 3 in this case. So the answer here is 3. Okay. Now let's take a simple example and see how it works. Okay. Let's say we have just a simple 3 by 3 grid. Okay. Which is 1. Okay. 1, 0 and 1, 0, 1 and 0, 0, 1. Okay. Now, given this grid, how do we find the connected regions? If we follow the same process, here, if we go from 1, okay, the connected area is this one, and from here you can also go here. Beyond that, it is not available. And here, these are the two things. So, the number of connected areas is 2 in this case. But how do we do this programmatically? So, let's give numbers to this grid so that it will be easy for us to understand. Okay. Let's number them as 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So now when we are at 1, we can, so at each step, let's mark these things as, let's start with the first one that is on the matrix, which is cell number 1. So when we are at 1, let's mark it visited and see how many can we visit from there. So how do we mark it visited? Let's take another number. Let's say 2. which represents visited cells. Okay, I marked cell number 1 as visited, or let's update this itself. This becomes 2. Okay, now from here, where can I go? To my neighbor, which is second cell. This also becomes 2. So from here, where can I go? I can't go anywhere. So I'll go back to 2. Is there any, I'll go back to 1. Is there any other cell that I can go from here? I can go to 4. Okay. This also I'll update to 2. So is there any other cell that I can go from 4? No, there is nothing else. So this is one, one count for me. Okay. If you maintain a count, this is one count. Now let's look at where we find the next one. So do we have a one anywhere here? Anywhere here? No. Our next one is at 6. Okay. So at 6, again we'll follow the same thing. It is visited, so we mark it as 2. Okay. Then is there anywhere else that I can go from 6? I can go to 9. So I'll mark this as 2. Is there anywhere else I can go from 6? No, I can't visit anywhere else. Is there anywhere else I can go from 9? No, there is no other way. So that completes this land area. Now I will increment the count by 1. Now, is there any 1 left in the matrix? No, there is nothing left. We have visited every one of them. So that means our count here is 1 plus 1, which is 2. Okay. So the reason for marking this visited or setting it to is because we don't want to visit them again. So let's say we visited this from 6. We can visit it from 9 also, right? Which will make it double count, which is why we have to mark them as visited. Okay. So the algorithm is pretty simple. We start at the first land node, which is the first one in the matrix, and we keep visiting whatever is accessible from there as long as we can access it. Once we finish the accessible points from there, okay, we will mark it as one island. Okay, then we'll go to the next available land location and we will keep doing the same thing. We will access all the neighbors that can be accessed from that point. Okay, so that's how we can do it. Let's write code for this. Okay, so first thing is we have to maintain a count. Initially, the count is 0. Okay, and we have to traverse the grid. Okay, it is a matrix, so we just do I less than grid dot length. Okay, I plus plus int j equal to 0, j less than grid of 0 dot length. Okay, j plus plus. So this will give us every cell in the matrix. So now we have to check if the current grid is 1. Okay, only then we will find the total area of the island. Okay, grid I of j is equal to 1. So that means we found some land piece. Okay, so we will increment our count. And what will we do? We will visit all the neighbors of that land. Okay, and mark them visited. So that will cover the total area of the that land accessible from the current location ij. Okay, so then the loop will continue and we'll go to the next available one and we will visit all the accessible nodes from one. Okay, so this is a algorithm. Finally, we have to return count. So we have to implement the visit function as well here. So how do we visit it? What is our definition? Whenever we visit a cell, we mark it as 2 and we visit all its neighbors. Okay, we have a grid and we have the starting position from where we should start our visit. Okay, now first let's just check the boundary conditions. Boundary conditions is if I is less than 0, j is less than 0, I is greater than the length of the grid, or j is greater than the row length and column length, basically. All the boundary conditions. Okay. So this if ij is not within the matrix, then we just return. That is anyway water. Okay. Now there is another condition that we have to check. If it is visited, that means if the grid value is 2, or if it is water, water also we can't go and visit, or it is not connected to the land, then we don't have to do anything. We just simply return. So this means we already visited. 2 means we already visited it earlier, this piece of land. 0 means it's not even land, it's water. So we don't have to do anything in this case. Now we are done with all the boundary cases. So we are with a new unvisited land. So what do we do in this case? We set it to 2, marking it visit. Okay. And we visit all its neighbors. How do we know the neighbors? Neighbors is I minus 1j. Okay. I plus 1j. Okay. So all the four sides of the current cell. Okay. And grid I j minus 1 visit grid I j plus 1. Okay. So this will give all the four sides of the north, south, east and west side of the current cell. Okay. So that should visit all its neighbors recursively. Okay. Let's run this and see. Okay. We got a wrong answer. Let's see what went wrong. We are visiting the, okay. So we are always getting count as 0. That means we are never entering this if condition. So if you see, our grid is character grid, whereas I looked for number, which is the mistake. So I should look for character one, which is with single quotes. Let's run it again and see. Okay, so this time sample test cases passed. Let's submit it and see. Okay, so this is successful. So what is the time complexity? Time complexity is order of m by n. That is because we are visiting this grid, each grid exactly once. Okay, so that's all we have for this problem. So this visiting is nothing but in a way traversing all of the neighbors, and it is very similar to DFS. If you can think of it in terms of DFS and try this without recursive using a BFS implementation, that would help you. Thank you for watching.